So I sent out a plan, a schedule. However, we got a wrench in the schedule because I just found out our grades are due Wednesday instead of Friday. And so tomorrow we will review for our quiz and have our quiz. And Thursday I will hand out, it'll be your choice. We're only going to do one part of my project, which is the Pictionary Dictionary, if you want to do that. Or you can do the objective test, and I have a review for that. Okay, does that make sense? I the Pictionary Dictionary, I do allow you to do it in pairs because you do present it. I'm going to show you an example of one so you can start thinking about which one you want to do. So this one is a student of mine, that I had long ago was um, loved chess. He was one of those students that he would try to sneak into the computer lab and would actually try to skip classes just to play chess. I mean, he was that in love with chess. And so when I'm asking you to do a Pictionary dictionary, you have to come up with a theme. So, of course, his was chess. I give you a list of words, and you can use any word, but I give you a list just to give you some ideas. And you're going to come up with 25 slides based upon your theme. So, like this one was every slide, every picture he chose had chess in it. So, like on the list, one was acute angle. And so, when he was looking on Google Images, he saw that these two people were playing chess and he saw this acute angle. He gives me the definition and the picture. He did also include the links of where he got the pictures. You don't have to do that, but you will end up giving me the word, the definition, and then you will be presenting with your partner in front of the class to describe where you see that vocab word. So, like this was acute angle. He did adjacent angles when he presented. He was using the British flag as the adjacent angles. So you have, right? And then radius was the hands of the clock that they used. He had congruent pieces of the chess pieces. Squares was the chessboard. Line segment. So you like pick like any subject and you can like one thing you just describe like all the yeah. So one subject. Right, and each picture has to be different. You can't just use like I've had students do that where they try to use one picture for like five different vocab words. It has to be 25 pictures that are different and 25 words with the definition. So this, like I said, this was his. I was doing that in English class. And it's a nice, for those who are like, oh, I got to present, so I'm not going to do it. You really do want to start learning to present because in senior seminar, you're going to have to do lots of presentations. And this one, I allow you to present with one other person so that way it's not as stressful when you're up there. Why in senior seminar they have to present a lot? Yes, and it's like a state requirement. You have to, and there's people in here who are not from the Goodwill Center. So you're also presenting in front of people who are not actually like teachers or something like that. What your plans are for after school? So this is his Pictionary dictionary. I liked this one. I thought this one was good. But I've had others. If you want to see another one, like I've had somebody do it on uh, food before. Let me see. So this is somebody who did one on food, but you have to be able to say why you chose that. I mean, like, are you wanting to be a chef? Not that you just like to eat food. I want to know. Like this one did it on. So this one did it all on food. Okay, there you go. So you got to see those. Any questions on that? No. Okay. So let's go ahead and start our do now. Oop, where is the do now? Oh, it's over here. Okay. It's asking for surface area. Please, 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 when you are doing your quiz and your test, I lost my pen. Where did it go? Please make sure you're using the correct formulas because if you're not, I can't give you credit because you're not demonstrating the skill that it's asking you to do. So this is surface area. And we know this is a pyramid because it has an apex. They all meet at a point. The surface area formula for pyramids was 1/2 P stands perimeter of the base times the slant height plus the area of the base, right? So capital B is going to be the square, which is 9 times 9, which is 81. Your perimeter is 9 times 4, which is 36. Your slant height is 9.2. So surface area equals 1/2. Go ahead. 36 times 9.2 plus 81. Yep, that's what I got too. So that'd be 246.6 inches squared, and that's surface area. Okay, when you have prisms, it's a little different. This prism, because we're talking about surface area, which would be like paint or wrapping paper, the surface area of this would be the 2 hexagons area plus the area of the 6 rectangles going around. So the hexagons, you need to use the area formula of 1/2 times apothem times perimeter. The apothem is 8.7. The perimeter is going to be 10 times 6 because there's 6 sides. 1, 2, 3, 5, 6. So that would be 10 times 6, which is 60. All these rectangles have the same measure. They are actually they're squares. They're 10 by 10. They're 10 in length and 10 in width. So there's 6 of them, 10 times 10. And then you would add these together. So the hexagon, I have 2 of them, times 1/2 times 8.7 times 60. What is that? And then we have 6 by 10s, which would be 600. And you would just add these two together. So that would be 861 miles squared. We have two of, did we not multiply it by two?
I did 261 times 10 times what?
Hold on a minute. It should be
I think
2 times 0.5 times 8.7 times 60. Oh, yeah, you're right. It should have been 522. And then when I add those together, 1,122 miles squared, because we had two hexagons, not one of them. Okay, same thing here. You have prisms again. Your trapezoids would be your parallel bases, and then you have four rectangles, with two of them being the same dimensions and then two of them not. So trapezoids, I have two of them, and it's base 1 plus base 2 times height divided by 2. Now, since I'm multiplying 2 and dividing by 2, those actually just cancel out. For the trapezoid, your base 1 would be the 3, your base 2 would be 6, your height would be the 3.7. So 3 plus 6 times 3.7, which is 9 times 3.7. What is 9 times 3.7? And that's 33.3. Now that's the two trapezoids, right? Okay, now the four rectangles. You have two, the ones on the sides have the same dimension. And it looks like this is 4 going this way, and this is 4 here. So it's a 4 by 4, and we have two of those. So you have two 4 by 4s. You have one 4 by 6, which is this top one. And then this bottom one would be a 3 by 4. So 4 times 4 is 16, times 2 is 32, 24, and 12. And you have to add all four of these numbers together. You'd have to add the area of the two trapezoids and then all of these to get your total surface area. So it would be 33.3 plus 12 plus 24 plus 32. And that gives us a total of 101.3. And that would be miles again squared. So this over here is it's a hexagonal pyramid. Sorry, we know it's a pyramid because it has an apex up here. Hello, that's spam. It looked like my son's vocational rehab person, and the number looked familiar, but it wasn't. Okay, so now I get 1/2 perimeter times slant height plus area of the base. So again, perimeter is all the way around, and it's this length here is 6, and I have 6 sides. So it's 6 times 6 is equal to P, which is 36. My slant height is 11.3. Area of the base. The base is a hexagon, so you have to use the regular polygon uh, formula, which is 1/2 times apothem times perimeter. So that'd be 1/2. Your apothem is 5.2. Your perimeter is 36. So now I'm going to go ahead and substitute everything into my formula. I get 1/2 times 36 times the slant height of 11.3 plus, I did not calculate that yet, so let me put that in the calculator. 0.5 times 5.2 times 36 is 93.6. So then I would add the 93.6 to all of that I need to multiply out. So I have 0.5 times 36 times 11.3 plus 93.6. And that's 297. So how confident are we on surface area for our test? And if you came in late, I'm going to be forced to give the test a little earlier. I was supposed to give the test on Thursday, but I'm going to have to give the test tomorrow. But we will review for the first half, and then the second half we will have the test. Okay?
New material today?
Yes. Today we have inscribed angles. We are not going to be able to do sectors and arc length like we were supposed to because they changed the date on me. Ah, so volume. Volume has different formulas. Make sure you're using the correct formulas. So this is a pyramid. If you remember the little water activity that I showed, it was a whole 3-minute video. A pyramid has 1/3 the volume of a prism with that same base. So here we have the formula. All prisms is area of the base times the height, but since it's a pyramid, we have to divide it by 3 or multiply it by 1/3. So again, this is, boy, they like this hexagon. Good thing we already did it. The area of this hexagon is the same one as we just did. The area, the capital B of this hexagon is going to be 93.6 again, because it was that, if you look, it's the same hexagon. And then the height is 7. So it's going to be 93.6 times 7. Instead of multiplying by 1/3, I tend just to divide by 3 on my calculator because it's just faster. So 93, let me clear everything off. So it would be 93.6 times 7. And I'm going to divide this by 3. So I get a total volume of 218.4, and this would be meters now cubed because, or to the 3rd power because you're talking volume. So this is a prism, and it's going to be the area of the base times the height. Remember, with prisms, base is the 2 parallel sides. So it's the trapezoid is your base. So the area of this base is going to be that base 1 plus base 2 times height divided by 2, which my base 1 would be this 4 here, base 2 would be the 6, and the height is 2.8. So it would be 4 plus 6 times 2.8 divided by 2. So what is that? 10 times 2.8 divided by 2 is 14. And then my height is the distance between the two bases. So it's not the height of the trapezoid, it's the distance between the two trapezoids. So what's the height then? If it's the distance between the two trapezoids? Yes, it's going to be 6. So then I would take that, because this was 14. So I would just take 14 times 6, and that will give me my total volume, which is what, 84? And that would be meters cubed. Please do not confuse this triangular prism with a pyramid. This is actually a prism because the two triangles are parallel and congruent. Do you see that? Do you see the difference between this prism versus a pyramid? A pyramid has an apex where they all meet at one point. While here, do all the faces meet at one point? No. So you need to find the area of the base, which the area of the base is this triangle. To find the area of the base, then, the area of the base is going to be base times height divided by 2 since it's a triangle. Here's the height of the triangle. That's the 2.6. The base of the triangle that they're talking about is going to be where this height is drawn to, which would be 9, because these two are parallel and both of these are rectangle. This is rectangle. So see how it's drawn to this dotted line here? And that is also a 9. So it's going to be 2.6 times 9 divided by 2, which is, what's 2.6 times 9 divided by 2? 2.6 times 9 divided by 2. And then I'm multiplying this by the height. So that would be 11.7. Now the height that this formula is talking about is not the height of the triangle. It's the distance between the two triangle bases. So what's the distance between the two triangle bases? 4. This here is your height, because it's talking about the height of the whole prism, which is just the distance between the two bases. So we would take, this is 4, so you would just take volume is equal to 11.7 times 4. So that would be 46.8 centimeters cubed, because it's volume. So now we're looking at our circles. right? What do we know about tangent lines and circles? Oop, I went off. Assume that the lines which appear to be tangent are tangent. It's asking us to find the perimeter. Perimeter is all the way around. However, we're missing these two pieces here and here, right? I know that from here to here is 12. So what's going to be the distance from here to here? Not 12. 26 minus 12 is 14. Now, one of the theorems we learned about was that if you have a tangent, two tangent lines drawn to the same point, to the same circle, that these outside pieces are the same. So this is 14 here, right? Okay, so if I still need to find this piece, so if I could find this, these two would be equal. Well, if from here to here is 12, then from here to here is also 12. So 23 minus 12 is what? 11. So this piece from here to here is 11, which means that this is 11. Now you add all the outside pieces. So 14, 11, 23, and 26. Please don't add that 12 because that 12 is included in this 26. So you would add 26 plus 23 plus 11 plus 14. And that would be the perimeter of this triangle. Which would be 74. And they didn't give us a unit, so you could put a U for unit, or you can just give me 74. Okay, so here it says that if it's tangent, we're going to assume that it's tangent, right? And what kind of angle does a tangent line make with a radius or a diameter to a circle? So this is a right triangle right here. If this is a right triangle, I can use Pythagorean theorem, right? To find this secant. No, it's not a secant because it doesn't pass just the segment. Okay, the problem is you have to know the notation of CUDA software. This 7.6 is the radius. It's from here to here because it's in the middle. It's in the middle of this radius. If it was diameter, they would have put it right next to the center. It would have been scooched over. But what do I know about all radii of a circle? Like spokes on a bike. They're all equal, correct? So then what's this length over here? 7.6. So this whole length is going to be what, 15.2 when I add those two together or multiply it by 2? Now I can do Pythagorean theorem to find this missing length. So I would do 11.4 squared plus 15.2 squared have to equal c squared. So 11.4 x squared plus 15.2 x squared is 361. What's the last step we always do with Pythagorean theorem? Yep, yeah, take the square root. So square root of 361 is 19. So this length here is going to be 19. You have three more for review, which is kind of like the review for the test. I mean, we did surface area, we did volume, we did a little bit of the circles, right? Um, okay, so, and I have a chord, and a chord has the endpoints on a circle. So see here how you have endpoints on the edge of the circle? This is a chord. This is your center, and it's perpendicular to the chord. When you have a segment or a full radius from the center of the circle and is perpendicular, it cuts this chord directly in half. So do I have to do a whole lot of work to find x? No. What's x equal? Yeah, this is just 14. That's it. No work. Yay. Now, they want this radius. I know from here to here is 8.1, right? And then the other from here to here is 6.4. Isn't this a full radius when I add those together? And wouldn't it equal then the other radius because all radii are equal? So for this one, all you had to do is add 8.1 and 6.4 together. And that gives you this length here. So what's that? 14.5. And now this last one, you would have to use Pythagorean theorem again because I'm not given the other part of this chord here. What I'm given is this length here and this hypotenuse, which is the radius. So this would be A, B, C. So x squared plus 8.3 squared has to equal 19 squared. Let's go ahead and do.
How do you know when to use it then? Pythagorean theorem.
When you have a right triangle and you have two sides and you're trying to find a missing side length. Pythagoras. So I had two sides. I had 8.3 and I had 19. I had the hypotenuse and a leg. But I also know it's a right angle because it had the little box. And it's a triangle. So anytime you have a right triangle and you're looking for a missing side length, you can use Pythagorean theorem. Now, if you have a right triangle and you have an angle on only one side, then you use trigonometry.
Yeah, so when you use Pythagorean theorem, is using
Right triangle.
triangle and missing side.
Yep. I wanted to enter this. And then I have 19 squared. And in this case, because you're given the hypotenuse, be careful. We won't be adding these. We have to subtract the squares. X squared plus, what was it, 68.89? 68.89 has to equal 361. So you're going to subtract 68.89. So x squared is equal to 292.11. And now you take the square root of this. So second square root 292.11. And that gives me 17.1. Okay. So basically, if this was pretty easy to you, you're going to be good for our test. And I want to apologize now. I was told this morning that grades are due Wednesday, when last week I was told grades were due Friday. So that's why I have to bump the test up to tomorrow.
That's fine.
Okay? But that means it's less new material you have to learn. So, because that's what I told my lead teacher. I was like, well, that means I'm going to have to cut out a lesson. And they were like, well, do what I have to do. Okay. So today, before we start, I okay. Did everybody get a circle? Now you're going to draw a radius. Use a nice straight edge because mine does a line tool. So do it. So draw a radius. And then I want you to draw another radius. I want you to make an angle. Doesn't have to look like mine, but I just want a nice angle. Now, I want you to use your protractor and measure that angle. So yours is probably different than mine. Mine looks like it's like oh, mine's probably what, 92? But yours is probably different. I hope yours is different.
Mine's 92.
Oh, well, I wanted yours to be a little different than mine, but okay.
Hillary.
Okay, now this, has everybody got 92, 93? That's funny. This angle here is called a central angle. So this is going to be part of your notes. And since it doesn't allow me to write very well on, so right here, this central, okay? The reason why it's called a central angle of a circle, right? Oh, that scared me. What would happen if I kept drawing and met it all the way around? How many degrees would it would be 360, correct? Well, it turns out that since mine is 92 degrees, that this outside would also be 92 degrees. The central angle and the arc it intersects has the same degrees. Okay? So this is central angle. It's made from two radii from the center, and I made a central angle these two angles are equal. So this arc, so if I called this A, and I called this B, I would say that arc AB is equal degrees, right? Now yours may be different because it depends on what your angle measure was that you made. So you would put 92 here, you'd put whatever your angle measure was. So if this was 50 on your paper, you would write 50 over here, right? This was 75, then you put 75 here. Depends on your angle. Now we're going to draw an inscribed angle. So an inscribed angle is when we have a point on the circle. So I'm going to just put a point somewhere on the circle, okay? So I'm going to put a point, oh, I'm going to change the color so I can actually see it. So I'm going to put a point on, why isn't it letting me draw? Okay, so I have a point right here. And I don't know, I'll call, this was A and this is B. I'll call this, I can't call it C because center C, I'll call this D. Or you could call it E, or you could call it whatever you want to call it. Okay, now an inscribed angle has the vertex on the circle itself. So you're going to use your straight edge and you are going from this point that you intersected the circle here, I want you to draw a chord so I want you to draw A to D, and then you're going to draw B to D. If you like Star Trek, it kind of looks like the Star Trek symbol. Anybody here a Star Trek fan? Okay. Doesn't that look like Star Trek? Yeah. Okay, so when you're done with that, I want you to measure this angle. So mine is 46 degrees. Yours may be a bit different. Mine is 46 degrees. I don't know what yours is. So go ahead and measure your angle. Measure this angle right here. So did everybody get that? Now at your tables, I want you to compare your central angle. Oh, yeah, thank you. Sorry, I put the wrong one there. Thank you. I want you to compare this number to this number and tell me what you see. I want everybody at your tables to look at your central angle and your inscribed angle and see if you see a pattern. Because I was hoping people do different ones. What do you see? That the inscribed angle, if I multiply it by 2, it equals the central angle. It also is, if I multiply this by 2, it will equal this arc it intersects. Right? Do you see that? So either the relationship is, if I multiply this by 2, it equals the central angle that it's pulled off of, or it's half of the arc it intersected. Do you see that?
I did 93, I divided it.
I'll come and look. And I want you to draw another point and try it again in the same circle and see what happens. So just draw it, just put, and I'll show you, and then I'll come over there.
Yeah, it's 93 divided by 2.
What is 93 divided by 2?
46.5.
So were you between 46 and 47? Yeah. So over here, I'm gonna do it again. So I'm going to draw a point on the circle, and I'm gonna call mine E. And I'm going to draw those chords again. And now I'm going to measure this angle. And what do you notice when you measure that angle? What do you notice? But you're going to do it again. You're just going to draw another inscribed angle off from those points. And then you're going to measure. So put a point E somewhere here, and then you just do another one. And then measure your angles and see what happens. Well, you can pull it off the same point if you want way over here. Same point. Oh, do you think I did that on purpose? Yes, they should be equal because they're coming off of that same arc of arc AB. And remember, an inscribed angle will always be half of the arc it intersected. So if half of my 92 is 46, this other angle would also be 46. As long as I'm pulling off of the same arc, right? And that's called an inscribed angle. Did you find that interesting? How you made pretty pictures on your paper. Okay, so I'm going to go ahead and give you the lesson. Yeah, is that interesting? I find it interesting. Do you find it interesting? That's why I like teaching geometry, because I can make it a little bit more interesting than algebra. I try to make algebra interesting, but geometry, yeah, I have a lot more options. Plus I get toys like protractors and compasses.
I like how you teach algebra.
Oh, pretty cool. But you make it interesting after doing it for close to 30 years.
Yeah.
If I didn't, so then it'd be like, but you're like, could you imagine teaching math for close to 30 years?
That is a long time.
I know.
I haven't even, I'm not even that old.
I know. Well, my adult children are well, how old are you?
I'm 26.
Yeah, my youngest son is your age. Because he went to school. Yeah, those two went to school together. Okay, so let me pull up my PowerPoint. Is this isn't the one you guys have. Oh. Nope. Mine says Unit 5. not the one I. Of you do you think are going to want to do the project? Oop, that's you're going to do the project. Uh, aha, here it is. Okay. Oh, I couldn't. I'm going to have to erase that board. Let me erase the board so that way we don't have scribbles up there. So did anybody choose to do the extra credit fractal by any chance yesterday? Was it interesting or no? Did no? You don't have to say yes if you didn't like. Did you draw the fractal? Did you like the picture it made? Okay. He didn't like the picture. That's okay. Did you look up what fractals do? Yeah, mammograms. Actually, they made big breakthroughs in mammograms from fractal. Fractals have been used a lot in science now. Erosions with beaches, they can mimic what will happen by using fractal models. Anybody here play computer games? Nobody plays computer games? Okay, if you play computer games and you see clouds, those clouds are all done by fractals, by the way. Yeah. I was playing a computer game last night and I was on Discord, and the guy I was playing with turned out to be a new geometry teacher. And he was like, I need some good projects for my class. And I sent him that fractal one because I made that one. So, yeah. Okay, so slideshow. Oh, no, 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 no. I got to put in Cami so I can. There we go. Okay, so when we are talking about arcs, you have minor arcs and major arcs. A minor arc is less than 180 degrees. So minor arcs, you want to write on here, are less than 180 degrees. So, and notice how many letters do I use for a minor arc? 2 letters, okay? So when you're describing a minor arc, you use 2 letters. The major arc is greater than 90 or 180. See how on this other side here? So like if let's just say this was 60 degrees. Then arc ACB would be how much? It would be 300 because 300 plus 60 is 360. Yes. So if this central angle is 60 degrees, then this outside, this other angle would be 300, right? Because it has to add up to 360. Okay. And how many letters do we use for a major arc? 3. Now, if I had another point out here, let's say I had E, then I'd have choices. I could call it A E B, or I could call it A C B, and that would be the same major arc, right? As long as you begin and end with your B and A, as long as those are on the ends, you're good. Because I could also call it BCA, or I could call it BEA. Those would all be names for that same major arc, right? Anybody confused about that? Okay. So let's look here. It says, name the arc made by the given angle. So here's angle 1, which is our central angle, right? So what arc is it intersecting over here? How would I name this one? ZY or YZ. It doesn't matter. It could be either way. It could be ZY or it could be YZ. You only have to give me one, but both of those would be correct answers. Notice how I drew a little arc over it to signify it's a arc. Now, it wants the major arc for angle 1. So if here's angle 1 and major arcs are greater than 180, right? What would I call this? What would be a name I could call the major arc, which the major arc would be all the way, no F, is one angle 1, the major arc of angle 1 would be DGE, right? Or it could be, give me another one I could use. DFE, right? Any others? What about EGD? And what about EFD? Now, if you would have given me DGF, I would have had to mark that wrong, right? Because the major arc for arc 1 would be the whole circle that excludes this angle here, or this arc here. Okay, we all good with naming? And then the definition, even though we drew it, did we draw it on our piece of paper? The inscribed angle states that angle theta inscribed in a circle is half of the central angle, or half of the central angle, 2 theta, that subtends the same arc. So if I drew, let's say this was the center here, right? And I had this. This would be the central angle. This would be the inscribed angle. Let's just say this is 30 degrees here. What would the central angle be then? 60 degrees. And what would arc AC be? 60 degrees also.
The inscribed is 20 degrees.
I just said if it was 30, right? 30 degrees. Inscribed angle is equal to 30 degrees. There. Okay. So if I have this angle here is 86 degrees. And it's asking me what KLM's measure would be. And it's saying arc. So here's K, here's L, here's M. So it'd be going around this outside here, right? What would this arc measure be? Well, how would I find it? Well, what do I do with 86? We just did it on our circle paper. Times it by 2. That's it. So it'd be 86 times 2. What's 86 times 2? 172. Now, Ella, if I wanted to find the other side, now I would subtract 360. So if I wanted to find MDK, then I would take 360 and subtract the 172. Does that make sense? Okay. And what would I do here then to find AB? Just times it by 2. So this would be 60. Uh-oh. Close your eyes. Close your eyes. Okay. Now it got a little bit trickier where I have to think because I'm not just multiplying or dividing by 2. So what does the whole circle have to add up to? 360. So this measure of this arc would be 118 plus 96, and then I subtract it from 360. So 118 plus 96. What is this? 214. And now I just take 360 minus 214, and what do I get? 146. Okay, that's this arc measure of KL. So arc KL is equal to 146 degrees. How do I find the inscribed angle? Divide by 2. So to get angle KML, this measure, you would take 146 divided by 2, which is equal to 73 degrees. So this would have to be 73 degrees here. So I have to know that a full circle is 360 degrees, right? And from there, I'm going to have to use some deductive reasoning skills to be able to find missing arc or angle measures. Some of these get a little trickier. I don't know where that came from. Okay, so if a full circle is 360 degrees, when I have a diameter, what does a diameter do to a circle? It cuts it in half, correct. So this side is 180. This side is what? 180. So when you look at these, you want to make sure when you have diameters. Oh, how in the world did I get the triangle? I didn't want the triangle. Diameter. Here's diameter. I just wanted it in color here. So I have diameter AB. This side would be 180 degrees. This side would be 180 degrees. What is arc CB's measure? 74. So they wanted this missing arc over here. So what am I going to do with 74 degrees? Not divide by 2. Subtract it from 180. Because remember, this is a semicircle. It cuts this circle in half because it's a diameter. So this side has to have a total of 180. This side has to have a total of 180. So to find this missing piece here, if this arc is 74, I would just subtract the 74. And what do I get? 106? So this side would have to be 106 degrees.
It's still 37 is the central.
And now we get, oh, lovely stuff. What's the relationship, again, of an inscribed angle and the arc it subtends or intersects or cuts, however you want to say that? What would I do to this here so I could set it equal to this over here? Yeah, I have to multiply it by 2 and then set it equal. So 2 times 9x plus 11 has to equal 20x plus 10. What's it asking for? Well, that's weird. They didn't tell me what they're asking for. Well, we'll find x and we'll find the measures also. So what's 2 times 9x is 18x. 2 times 11 is 22. Has to equal 20x plus 10. I go ahead and subtract 18x from both sides. I get 2x plus 10 is equal to 22. I subtract 10 from each side. I get 2x is equal to 12. And I divide by 2. And so what does x equal? And if I have 6, I could substitute in to find the inscribed angle. What's 9 times 6 plus 11? That would be 54 plus 11, which is 65. And if I take 20 times 6 plus 10, that would be 120 plus 10, which is 130. I could also check my answer. If I have 65 and I multiply it by 2, does that equal 130? Yes. So I did it correctly. 65 times 2 is equal to 130. Okay, let's go. Let's look at this next one.
First thing you do 45 times 2.
Yeah, what is 45 times 2? It's 90. So in this case, you would just take the angle measure and multiply it by 2. That's 90. Has to equal 14x plus 6. So if I subtract 6 on each side, that's 84 is equal to 14x. And divide by 14, x is equal to 6.
Yeah, you put 6.
If you substitute in, you better get 90 or something's wrong. Do I get 90? Yes, because 14 times 6 is 84 plus 6 is 90. Yep. Okay. Sorry, I was just deleting some of this stuff. Okay, so we are on number 9, right? Here you go. Okay, so how would I do this? Any ideas? Well, what does a circle all equal? 360. So from here to here would be 9x. No, it's not. You don't have a diameter because it's not going through the center of the circle. You're going to multiply this by 2, and that's going to equal this arc over here. So the 18x plus 28 has to equal this arc, right? Now I have all the outside arc measures, right? Samo, well, what does a circle have to all add up to? 360. So you would just take 18x plus 28 plus 7x minus 8 plus 13x minus 2 has to equal what? 360. So the trick was to notice that you had the full circle on this one. Since I didn't have any of the arcs that it subtends, I couldn't set it equal to anything else. So I have what? 18 plus 7 plus 13. So I have 25 plus 13 is what? 38. 38x. I have 28 minus 8 is 20, minus 2 is positive 18 is equal to 360. Now you would subtract 18 on both sides. That would be 342. Divide that by 38. And that equals 9.
All that work to get 9.
Mm-hmm. And depending on what the question would have asked, I don't like this part because it doesn't tell me. I could find arc RT or arc RS, or I could find the inscribed angle, right? Okay. This one's a little trickier. I'm going to let you all try to battle this one at your tables, and then I'm going to help you in a minute. But I think that this would be interesting for you to try to figure out a little bit. You don't want to try. Well, that's not a good way to proceed. I know. I don't want to try. RQP is going to have to be 224 because of this inscribed angle of 112. 112 times 2 is equal to 224, right? So all the way around here is 224. Now, I could find QP by subtracting 150 and 224. Do you all agree with that? I love these because they're like puzzles. But I'm weird that way. Like, I love doing puzzles when I'm at home. So this QP is 74 degrees, right? Hmm? I like math puzzles. Okay, so I know. Playing Scrabble though, because it is actually more of a math game than a word game. I can kick butt with just 3 little words. Okay, so I now have, I know here, I'm trying to change the color and it didn't change. I know here that Here's 65, right? Let me make this point a bit thicker so you can see it better. Oh, that didn't help. Okay, good. And why didn't it change it? Come on, I want this to change to 4 point. Okay, so see this inscribed angle? And it's these two arcs added together is this full arc, right? And here's the inscribed angle for it. So if I take 65 times 2, I can now set that equal to 74 plus 8x minus 8, which I get 130 is equal to 74. I'll go ahead and subtract that. What's 74 minus 88? What was it? 74 minus 8 is 66. So 8x plus 66. You subtract 66 from both sides. I believe you get 64 equals 8x. Divide by 8. And x is equal to 8. So these get tricky. These can get tricky because you have overlapping pieces and you're just trying to find missing pieces.
My problem is I don't know which one to start.
And here's my key.
Like, if I could just put an arrow to say start here.
And it doesn't, because in real life, if I was a plumber and had weird things happening with circles, there's not a start here. Here's some information, and you have to go off the information given. So, number one, look for diameters, because what does diameters do? They cut a circle in half. And you can only assume diameter if it goes through the center of a circle. Not all endpoints of a segment that goes through a circle are diameters. It has to pass through the center. Look for angles, and angles formed with the vertex on the center to the circle. The opposite arc and the angle measure that the circle subtends are equal. Look for inscribed angles. An angle formed with a vertex on the circumference of the circle. The angle measures half the measure of the arc it subtends. Now, the big thing is mark all what you know, and then you have to think. You have to use your deductive reasoning skills. This is what's different than algebra. Algebra, I can give you step by step by step. Circles, when it comes to this type of stuff, is not step by step by step. It's, I'm going to mark what I know, and then I have to use critical thinking skills to find everything else. Okay,